Hello, and thank you for attending this presentation of the DECODER platform for software analysis. I'm Virgil Prevosto from Cialist in France, and I'm acting as technical leader of the DECODER project that I'm about to present. In a few words, DECODER is an Edge 2020 project started in January 2019, meaning that we are now nearing the end of the project. Its main aim is to provide a unified platform, the Persistent Knowledge Monitor, or PKM for short, for holding and managing all types of documents that are used throughout the lifecycle of a software system. This includes, for instance, design and requirements documents, the code itself, of course, its comments, user manuals, formal specifications, if any, test and static analysis reports, and so on. As I said, the PKM is meant to be used along all the phases of the software development cycle, and for reflecting that, three main roles have been identified. Developers, who need to write the code, reviewers, who assess whether the code is fit for release, and maintainers, who have to come back at the code base sometime later, sometimes much later when little information is still available for the code. In order to accommodate their various needs, some work in DECODER has been dedicated to propose methodological guidelines supported by a convenient user interface and deployed over a set of use cases. Finally, there are two main categories of tools that are meant to interact with the PKM itself. On the one hand, software engineering tools, static analyzers, test case generators, modeler, and so on. And natural language processing tools for finding correspondences between the various documents put into the PKM. Since it is supposed to handle very heterogeneous sets of documents, at its heart, the PKM itself is a document-oriented database, namely a MongoDB instance. On top of MongoDB's JavaScript API, the PKM core API provides very low-level functionalities for managing the database. It can be accessed directly from the command line, or through a JavaScript SDK, for instance, to integrate a new tool to communicate with the PKM. But for everyday usage, there's also a higher level API in the form of a RESTful HTTPS server, which uses requests described with the Open API framework, which means that there are bindings readily available for a wide variety of programming languages, facilitating, of course, interoperability. Similarly, the deployment of the PKM and its tools is facilitated by the use of Docker containers and Docker Compose scripts, depending on the set of tools that one wants to deploy on a given platform. Finally, the API is available through open source licenses, namely AGPL and Apache, and can be found on OW2's GitLab at this URL. As I said, several tools have been bound to the PKM during the DECODER project. First, among software analysis tools, we find Tester, a test generator for graphical user interfaces, Pharmacy and OpenGML, formal verification tools for respectively C and C++ and Java programs. We also have GMLGen, which is aimed at generating simple GML annotations from Java code, for instance, to assess that an object is never null when given to a specific method. Then we find language processing tools that extract information either from the source code or from the accompanying documentation, and attempt to find correspondences between the documents. notably to trace the implementation of the original requirements of the system within the implementing code. Another important aspect of DECODER is the development of the SFM language for abstract semi-formal modeling, which is meant to act as an intermediate step between natural language documents and fully formal specifications. I'll come back to that in the next slide, but for now I'd just like to mention that there are prototype tools to convert to and from SFM documents. Finally, we have a browser-based front-end for the PKM and its associated tools, which also has the ability to use the Jupyter notebooks to deal with the PKM documents. Focusing now on natural language processing tools. In the context of the extraction of information from the source code itself, it has basically been used for two main things. First, to identify potential variable misuse within the code, and more generally to suggest some code repair for simple cases. For instance, to propose what the tool thinks is the appropriate symbol when a misuse has been detected. In the other direction, from natural language to code, most of the work has been dedicated to semantic parsing and semantic role labeling in order to identify the entities described in the documentation and to be able to map them to variables and functions in the code. This has also resulted in a first version of the traceability matrix builder that aims, as I said, at showing the user, and in this context, the reviewer role, which parts of the code implement a given requirement. Regarding SFM, first version of the language has been defined for describing state machines diagrams in particular, and various tools have been developed on top of it. First, it's possible to generate SFM diagrams from standard document formats, PDF and docx namely. Potentially we're using custom definitions if a user-defined parser is given in addition to the command tool. The reverse direction, the generation of docx or PDF from an SFM diagrams is of course also possible. And we also have tools to generate directly SFM templates from code or implementation. First, tester can generate diagrams to display the information it has gathered from the UI under test. And another tool is Excavator, which has been developed to abstract away the internal state of the Linux kernel in order to provide an appropriate context for the analysis of a driver, which is one of the use cases of DECODER, as we will see in the next slides. Finally, SFM diagrams can be animated by a graphical debugger that uses information given by GDB and displays them according to the abstractions made in the diagram. We'll briefly speak about the front end now. So as I said, it is browser-based and uses the popular AngularJS framework. It first provides basic support for the main tools feeding the PKM, such as GMLGen, Testar, Pharmacy, and so on. It has also a dedicated view for the traceability matrix between requirements and code. And as I said, you can directly import Jupyter notebooks within the front end and interact with the PKM that way. It is under heavy development right now, especially with feedback from the use cases. Namely, PKM Tools and the PKM itself have been experimented on all the projects that have been selected as use cases in the first phase of DECODER. Namely, for C, 2 drivers from Linux, a simple watchdog, and a more involved Ethernet driver. For C++, we rely mainly on the OpenCV 2D graphics library. And for Java, there's a sample restaurant reservation system called MyThaiStar, which is meant to showcase best practices, and 4 OW2 projects: OZ-Force, Joram, Lutis, and Site4G. In addition to experimenting with the main platform, as I said, this was also the occasion to develop new helper tools, namely GMLGen and Excavator, as well as experimenting with Doc2 SFM. Furthermore, we also gathered data to enhance the result of NLP tools, since, as always with AI-based techniques, it is important to have a sufficiently large training dataset to obtain suitable performance for the tools. So, in summary, the work done so far resulted in a fairly robust infrastructure for the PKM itself, with a good connection with the individual tools that are meant to interact with it, and interesting results on the use cases. Regarding what we want to do in the last 6 months of the project, first we have to finalize the UI and to adapt the methodology based on the work done in the use cases. Similarly, individual tools need also to be enhanced to better match the users' needs. And finally, interactions between the tools need to be refined. On the one hand, by extending SFM and its accompanying tools to propose finer descriptions of the code, and on the other hand, by reinforcing links between NLP tools and SFM, acting, as we said before, as an intermediate step between informal documents in plain natural language and fully formal specifications. Okay, so this concludes what I wanted to say about DECODER. Thanks again for your attention, and feel free to ask any question now, or to contact us through your favorite channels.